the story so far with VMM is that we've learned that it's for a large implementation of a highly virtualized or consolidated environment with virtualization of a data center, not for your typical small environment, not probably for your environment that you find yourself in with the scenario of the assignments. Okay, so just as a side note, if anyone is giving me a solution in their virtualization that involves the virtual machine manager, I'm going to be challenging you on the expense you have to firstly pay for the VMM, and secondly, the need for VMM considering the size of the enterprise or the company you're dealing with. All right, so let's go on with what we're talking about today. We're talking about creating and managing VMs with VMM, Virtual Machine Manager. So, yeah, not something that's totally crazy and out of bounds for what we've been doing, but we've done it with Hyper-V, but we'll look at doing it with VMM, and we'll see that there's some differences, mainly the same, but there's some differences. So we'll be creating virtual machines, we'll be cloning and converting virtual machines. So let's actually have a quick look. So what is a virtual machine checkpoint? So we've already spoken about this, and we know that checkpoints are effectively what we understand as snapshots from VMware Workstation. Just different words, different way of actually expressing the same thing. So based on that knowledge, we know that once we create a snapshot or a checkpoint, that virtual hard disk is frozen in time, isn't it? So basically a non-checkpointed VHD is just a single file, single disk. But after you create a checkpoint, that original VHD is actually frozen in time. Okay, it's frozen in time because the data, the settings, the configurations, and everything on there has to be that point in time. It can no longer change. When I say frozen in time, it's basically it's a read-only copy now, if you like. So what about when you actually make changes to the virtual machine, to the configuration, to the setting, to the data of the virtual machine? Well, they still have to happen. Obviously, there's no point of a snapshot or a checkpoint if you cannot no longer modify the virtual machine anymore. So you can't modify this original virtual hard disk file, but what happens is you spawn off a secondary and virtual hard disk file, and in this case, it's got the AVHD extension. So that's basically a spawned virtual hard disk file. So if you like to think of it, it's like the differences between what's on the data here on this virtual hard disk and the changes since that checkpoint or snapshot. So let's say we've this is a snapshot of a file server, and then after we took that checkpoint, we added 100 gigs of data because we just basically acquired this new company and we incorporated their storage or their file server into our file server, and we incorporated 100 gigs of data. That 100 gig is not written here. It's actually written on the new AVHD file. Okay, so checkpoint creates a AVHD or VHDX. So obviously the X, whether the presence of the X, does anyone know what that X actually means? Any takers on that one? Guessing what the X actually means? Okay, yeah, good one. So who was that? Alex? Yes, generation 2. So if you remember, we talked about generation 1 and generation 2, and when you create a generation 2 virtual machine, it has the VHDX, or in this case, AVHDX. So all subsequent changes are written to the AVHD or AVHDX file, and when we revert to the when we revert to this checkpoint, this differencing disk, if you like, difference disk is deleted. Okay, so that's any changes, any modifications is deleted. In my example, I was talking about just then where we've got a file server and we've added 100 gigs of data, and we realize, hey, we shouldn't have done that. Or maybe there's been a problem, or we realize we shouldn't have done that. but we don't know which files are being added and which files weren't added, we could just revert to the snapshot or checkpoint, and all of those changes that we made since the checkpoint will be deleted. It's like it's never happened. I'm sure you guys will understand that because we've been working with VMware snapshots all along. So let's talk about cloning. So again, cloning is not a new concept. Okay, it's easy enough for all of us to understand. We have a virtual machine. We can create. So let's have a look what we're doing. We're cloning and converting virtual machines. So cloning, we could have a virtual machine. We can create another virtual machine based on the original virtual machine. But before we talk about cloning, let's talk about creating a virtual machine in VMN or Virtual Machine Manager. So the wizard is different. It looks different, but the choices are very similar. So when we create a new virtual machine, we use the create virtual machine wizard, and that basically walks us through with all the requirements, and you can accept the defaults, or you can actually make modifications. You can use existing resource such as a machine template. So we spoke about the idea of templates last week, and that's the same idea as using the golden master that we've been using. We can use existing resources such as a virtual machine template or virtual hard disk files. So if you remember, one of the first tasks we did when we created our 5SV virtual machine infrastructure was to import a new virtual machine based on the virtual hard disk files. Or we can create a brand new virtual machine from scratch. We can configure the hardware. On the configure hardware page, it provides many options, okay, virtual hardware options, obviously. And there's an intelligent placement on host. Okay, so the intelligent placement is interesting. So let's say you have a whole bunch of hosts, Hyper-V hosts, and obviously when you want to create a new virtual machine, you have to put it on a host to run that virtual machine. So if we have 3 hosts, for example, and host 1 is at 60% capacity or utilization, host 6 is at 70% utilization, and host 3 is on 20% utilization. As humans, it's pretty easy to determine that we should put on host 3, shouldn't we? But this intelligent placement basically can do a couple of things. It can actually just tell us which host to put it on, or it can recommend which host we put it on, and when it's recommending which host we're putting the virtual machine on, it can do it based on a star rating system. So basically, we create a virtual machine with various hardware requirements, and obviously it assesses that against the capacity of the host plus the abilities of the host, or how much resources each host has, and places it or recommends a placement based on that. So here it is. If we look at this, we've got 2 hosts, the host 1 and host 2, and you can see there's a star rating system, and it seems in this example, the host 2 is a higher rated, which means it's more suitable, and that might be because it's got less utilization at this point in time. So Virtual Machine Manager evaluates the host capacity and performance and automatically places the virtual machine on the most suitable host, or it can make a star rating recommendation through the intelligent placement. So you can configure how automatic you want it to be. So if you make it a select automatic, it just basically takes you out of the equation, just puts on the best host that it thinks. But if you don't want to be that automatic, you can select it to be a rating system where it recommends which host you use. But based on that, you could see that, hey, both these hosts are suitable. Okay, if it's not suitable at all, it won't even show up on this list. But both of these hosts are suitable, but this one is recommended based on the intelligent placement assessment. But if you say, hey, I know that that's more suitable, and it's saying that, but I know that this one is actually the one with a higher CPU. Sorry, the CPU is a higher spec CPU, and I have more threads, and I know that that's running a few machines that's actually a few virtual machines which actually are, smaller spec, even though they will consume resources, but they're not going to consume the CPU resources as much as some of the virtual machines that I know is on host 2. Then I can manually just select I shouldn't have clicked on it. I could still manually just select host 1 even though it's recommending host 2. So intelligent placement can be automatic or can be a recommendation. What is virtual machine cloning? So we all know what cloning is. It's a rapid way of making a virtual machine. So I think in my demonstrations in previous subjects for IBM, for example, we could make a clone, a full clone even, within a matter of minutes. And depending on how, what we've done to the original virtual machine, this could be a complicated virtual machine which has hours and hours of work done to it as far as installing products, installing updates, making configuration changes, creating data. So we could have spent hours and hours of work to get the virtual machine 1 here to the state where it is in now. But through virtual machine cloning, we can create another instance of this within a matter of minutes. And basically, if you think about that, that's basically in a matter of minutes, you're just duplicating the work you spent hours and hours doing, possibly in the first instance. So it's a rapid way of deploying a new virtual machine. It basically makes a copy of the VHD or virtual hard disk files and the configuration files and the memory contents. So the original one can be online if using System Center configuration virtual machine manager. And so basically, what does that mean? You can clone a running virtual machine. That's what it means. The cloned virtual machine is a exact copy, so be careful. It's got the same identity. So do you guys remember what happens when we have 2 copies of a virtual machine with the same exact identity? What's the problem that could arise from that? Well, no. Same SID, exactly. The MAC address, it's a virtualization layer problem. So the MAC address can be changed during the cloning process, but the SID is actually a guest operating system problem. So that's not something that the virtualization can fix up straight away. So that's the SID, same SID. And SID stands for security identifier. So it's the security entity. It's like your student ID. If 2 students have the same student ID, that will cause havoc. Not only, but in this situation, because it's a security identifier, if that was a domain controller, and I just made another domain controller, it's who do I trust? How can there be 2 domain controllers with the same SID? So anytime you're using your Active Directory domain and you have the same SID, that will cause all sorts of problems. So that's a Windows security issue, and it's a security issue that's associated with domains. If you don't have domains, you just have work groups, it's not much of an issue because you rely on just a simple networking to interact with each other. So it's something to do with that. It's to do with Active Directory, because if you forgot, when we create an object in Active Directory, we give it a SID based on the RID pool. And if you remember, there's a RID master. So this SID is very important because it's unique to every object in the domain. So let's keep on going. So considerations. So the next page even says it. The cloned virtual machine has the same name, same domain SID of the original virtual machine. So it cannot exist in the same domain. After cloning, what can you do? What we did after when we cloned was use sysprep, if you remember, to manually change the SID. But having said that, what happens if it's an Active Directory server that you cloned? You can't sysprep a domain controller. So you also have to ensure there's sufficient disk space on the host. Obviously, you can't make a copy of a large virtual machine if there's not enough disk space to store that virtual machine somewhere on wherever the host is using as storage. So what about converting virtual machines? Obviously, we know that we know that Hyper-V is not the only virtualization hypervisor in the world. We know of VMware as probably the main competitor or main alternative, and there's also Citrix as well, and many others. So we can convert Citrix Zen Server virtual machines to Hyper-V using P2V conversion. So if you don't know what P2V stands for, it's physical virtual conversion. We can do V2V, or virtual to virtual machine conversion, and that type of conversion is supported in System Center 2012 VMM with these versions of ESXi. Okay, if you don't know what ESXi or ESX is, it's basically the hypervisor or hosts of the VMware vSphere suite of servers. And in System Center SP1, you can see that's limited. So it's later versions. So obviously, you need the latest information on the version of Hyper-V or VMM you're using. Okay, so you always have a look at these ones. So, but don't forget, guys. So, what if, I'll ask you a question. What if you had a virtual machine which was 4.0, let's say, in VMware ESXi, and now you've got this one and it can only work with it can only convert 4.1. What is those versions really referring to? What could you do? Any ideas? Yeah, update. What would you update? Yeah, some type of compatibility migration. Yeah. So you're on the right track, Alex, there. And if you remember, so this is the old one. Let me just create a new one. New virtual machine. If you remember, when we create a virtual machine, we choose the hardware compatibility. Okay. So let's say we choose a hardware compatibility of Workstation 5.0. This type of virtual machine is compatible with all of these ESXi versions, and when you create an ESXi, it's the same. Okay, it's the same. You create it based on the hardware compatibility. So I can check that box as well. And basically, if I do that, let's just keep on going. Oh, all right. And we'll just finish off. I won't install the operating system, obviously. All right. So I'm just quickly done that. And that's this one here. All right. So here you can see that that's if we actually look at this, look at the settings. We're actually with the hardware limited, and we can see that it's if we look at this, it's that one we just created. But within the VMware Workstation, I can actually upgrade this hardware compatibility. So it's basically upgrading to whatever version that we want to. So basically, we upgrade that. Obviously, if we're not talking about this migration to Hyper-V, we basically just add extra functionality and hardware limitations based on the version of VMware software you've got. But if we actually, back to our discussion, if we had something that was ESX 4.0 and we can only support ESXi 4.1, then we could just upgrade the hardware compatibility to 4.1 and then use the conversion to convert it again. Okay, so that's the hardware compatibility.